Thank you everybody for joining our today's webinar. So what are we going to see today? We've split the webinar Introduction to Python into 3 parts, and we have a Q&A session at the end. First part will be a basic introduction, so we'll talk about Python, what it is, why we use it, and what we're going to show you today. The second part is dedicated to some introductory examples, so we present some key concepts, some best practices, so that you get a first idea of the whole concept and everything you need to know to get started and how to get help. The third part will be an extended example, so we will use all the information that we have from the first or the second part and use it in a real-world application with the Python model. The fourth part is we will have a Q&A session at the end in the last few minutes. So let's get started. So the first part is the introduction. So just in case this is new to you, what is Python? So Python in a nutshell is a powerful programming language, which means it's been around for a very long time, and we think it's very easy to learn, and it's available for all major operating systems. So it doesn't matter if you run it on Linux or on Windows, you can use it on the platform that you like. The nice thing about Python is that it's not only for beginners or for a certain group of people, but it's also for professional developers. So it's not only for the prototyping, but you can also use it for production, for deployment of your software system. We will see this later, but Python has a very clean and simple syntax, so it's very easy to read, and it's also very easy to get started and write your first code. Python is an open source software, which means it's not only that it's available for free, but it also got tons of ready-made libraries, so you can download them from the internet and use them for your own project. Having said that, Python is a programming language, but it's also a good language for mathematical modeling. So there are many popular packages for scientific computing that are available. Free packages, you see a few here on the slides. And there's also another tool that we will introduce shortly that is called Jupyter Notebooks. So this is a development environment that is very nice, especially for demonstration purposes, and to build like small notebooks that contain a lot of information, that contain text and code. We will see this in a minute. So the nice thing about Python is that the language itself has many features that look very similar to mathematical notations. So that means the conversion from mathematical models to Python code is really very easy. And you can extend the language to your needs. We will also see this in a few seconds. You might ask yourself, why Python? So there are many programming languages out there. And it's an important thing to see that Gurobi is committed to all of these languages. So it's not that Python is more or better supported than other languages, but it's we choose Python today because we think it's a good start. It's simple to learn for new users. And we also think that Python has some special features that that makes it really easy to build and maintain optimization methods. But of course, you can use Gurobi with your favorite programming language, and some things look very similar, some things a little bit different. It really depends on your application. Okay. So how do you install Python? First of all, good news, if you already installed Gurobi on your machine, then you already have Python. Gurobi comes with a small Python distribution with a basic set of packages. So in fact, if you're starting the Gurobi interactive shell, it's a Python interactive shell that you're starting. And Gurobi is not limited to specific Python distributions, but we support the wide range of Pythons that are available out there. For this specific presentation, we use Anaconda Python. Anaconda Python has some very nice advantages that we will see. You can download it for free from the website. It's available for all the major platforms. And it already comes with some basic packages in the default installation, so you don't have to worry about getting all the things that you need to get started. What's very nice about Anaconda is that it also has its own package manager that makes it very easy to install further packages. We will see this. For Anaconda, Gurobi provides packages, which means Gurobi itself provides those packages. So if you use Anaconda and if you install the Gurobi package, then this was already built for you by Gurobi itself. And one question that always comes when it comes to Python is what version to use. So there are basically two versions out there, which is Python 2 and Python 3, and the latest version of Python 2 is 2.7. So we recommend to use the latest version of Python 2.7 unless you need to use version 3. Before going to the models, let's look at some basic concepts of Python. Python is an interpreted language. That means for some programming languages you need a compiler. So the workflow is always to write some code, to compile, and then to execute. And Python optimization is done in the background. So there is some kind of compiling, but you don't see it. You write your code and you can run it immediately. And basically there are two ways to use Python. So the first way is you put all your code in a simple text file, typically with the extension .py, and then you run a command. So you execute the script from the Python command line. So the second thing that you can do is you use the Python interactive shell. So this is a Python environment that you can use, and you can interactively type commands, see the output, and change things as you go. So from these two basic ways to use Python, we will go one step further, and we will use Jupyter Notebooks. Jupyter Notebooks has the advantage of being interactive, like the interactive shell, but it's also a graphical environment that you can use to create your Python code. It has some very nice features as well. So let's take a quick look at Jupyter Notebook. Jupyter Notebook itself is a web application, and it allows you to create text and share documents with live code, equations, visualization. So much like a real notebook, but it's a web application that runs on your local system. So you can open up your browser, and we will see this in a minute, and get started. Jupyter Notebook, just like Python, is free software, and for a bit of history, was born of the IPython project. So maybe some of you know IPython notebooks, so this is the new version if you want to. So starting is quite easy. If you use Anaconda Python, it's already installed. You just open up your command line and you type Jupyter Notebook, and then a browser window will start, and you can start immediately. So feel free to visit the website to get more information, but you will see a Jupyter Notebook all throughout this webinar. So we have Python, we have an environment that we can use for coding and for modeling. So how do we connect everything with Gurobi? Basically, there are two ways to do this. For Anaconda Python, it's especially easy because you can just use the Conda package manager. So it's two commands. You need to tell the package manager where to find the package, and then you just type Conda install Gurobi. On this slide, on the right side, at the top, you see the output. So this is from my Windows machine, and this takes a few seconds. It downloads the latest version from the internet, and then you're ready to start. In case you need more information for your specific platform, we have an online documentation, so you can just open the Gurobi Quick Start Guide for your platform, whether it's Windows, Mac, or Linux, and look up how the installation works. And there's also a second way to install Python that you would use if you use another flavor of Python, and this works by changing your working directory to the Gurobi installation directory. And then you just run Python and you setup.py install. So this executes a setup script that will copy the appropriate packages to your Python installation. And that's it. At the end, you have the Gurobi Py module installed within your Python installation. And then that's everything you need to use the Python API for Gurobi. So before we start with the first example, let's look at a bit of context here. If we talk about modeling, if we talk about solving models with mathematical optimization methods, this is usually part of a larger application. And this is a structure that you see all the time when it comes to solving problems, decision problems, planning problems, and it looks like this. You usually start with a business problem. You need to plan something, you need to decide something. So you have a set of data, you have parameters, you have information, and then there is a specific situation. And what you usually need is a software component that we call a model generator. So a model generator is the part of the software that takes all the data and that knows how to create a specific model instance from this data. So that means out of the problem structure and out of these set of rules and this code that generates the model, you end up with a model instance. So this is the specific ready model that is the input for the optimizer. So once the optimizer is finished, you need to somehow retrieve the solution and do some analysis. For example, if you did some planning, you want to look at the decisions, you want to analyze it, visualize it, something like this. And then maybe you're fine, but maybe you notice something and you say, well, we need to change this a little bit. So actually it's a cycle. So if you want to, you can change the problem instance a little bit, or you tweak the model generator. It really depends, but it might be that you go through this cycle several times and then you're happy. In this webinar, we will see several components of this cycle. So the first example will just be, we have a model instance and we put it in the Gurobi optimizer, and then we will take other things into consideration. We will see the Python API is usually what you would use in the model generator. So given the problem instance, we write the model generator, and then something goes on. And the third example that we're going to see is the full cycle. So we start with the problem instance, we see how the model generator works, we see how the optimizer runs, and we have a nice view at the solution. Okay, so let's get started. This is part 2, and we will do this as a live demo. So I will open up Jupyter Notebook now, and it works like this. I open up a command line. Well, this is my Windows machine. So what I have to do is I have to activate with Anaconda the environment that I'm using, that I called it webinar. So, and I start Jupyter Notebook. And that's it. It starts the local web application and opens up a browser windows, so we can get started immediately. So let me show this on the screen. So this is it. So this is my local browser, and this is the set of notebooks that I have created for this webinar. So we can select a notebook and open it, and it will open up in a new tab. So before we look into the details, maybe a few things about notebooks. What you see here is a set of cells. So we have a set of cells here, and cells can have two different types, or more than two types, but we will see two main types in this presentation. The first one is Markdown, which means formatted text. So we can enter Markdown code, then we press Shift Return, and this gets converted into a nice graphical version of what we just defined. And this works with formulas and equations. We will see this in the next few examples. So, and the second type of cell that is very interesting is code. So code allows us to execute Python code in a running environment in the background. In terms of Jupyter, this is called a kernel. So you can imagine that this is a shell, a Python shell, interactive shell, running all the time, and you are able to execute commands or sets of commands. So, and what happens when you execute a command is that you can see the output immediately. So let's take a look at this notebook and see what happens. So this is a code cell, and the first command that you also need to work with Gurobi is you import the Gurobi Py module. So we use the import statement, and then I press Shift and Return, and this gets executed. So this has no output, so we don't see anything. And now what we will do is we will read a model instance that is already on my computer, and we will solve it. Maybe you noticed that when I opened up this list, that we have 3 notebooks, but there is also an MPS file. So this is an MPS file from the examples directory of Gurobi, and you can open it, and it's a model file. So the first thing that I'm going to do is I'm going to read this model file into a model object. So we will hear about model objects later, but this is what happens here. We create an object that is called model, and then we call the read function to read it. So this has also no output, but now you can see on the left side we have numbers next to the cells. So this means we can see the order in which the commands were executed. So now I have this model object, and the next thing I can do is I can call the optimize function on this object. So the model instance is already there, the model generator already did its work, so we can call optimize and see what happens. So I also press Shift Return, and what we see here is the output on my system of Gurobi optimized. So we see that there's something happened and the problem was solved, and that there is an optimal objective value. So next question would be, okay, the problem was loaded, it was solved, but what next? And of course, what you would do next, and you remember the cycle, is you want to retrieve the solution and you want to analyze it. So you need access to the data that is available. And this is done by accessing attributes on objects. More details in the next example, but for example, what we can do is we can just enter the name of an attribute in the notebook here, press Shift Return, and it outputs the value. So this is the objective value. And maybe we also want to output the values of the decision variables of our model. There's a function available that is called print attributes, and what it does is it's a function of the model object, and it prints all the variables and it prints all the values of a certain attribute that have non-zero values. And in Gurobi, the name of the attribute that contains the solution value is X. So pressing Shift Return gives me a list of the name of the variables and their values. So, and that's basically it for our first example. So remember what we did. We loaded the module, we read the model file, we called optimize, and then we were able to inspect the solution and look at the decision variables. Okay, let's switch back to the slides and see some more. Okay, so the next thing that we're going to look at is, and this is basically where the Python API is so important, is the model generator. In order to use it, or in order to create your own model generator, I think it's important to understand some basic concepts about Gurobi. The first thing is Gurobi has attributes. So attributes are properties of the objects. So it means a model can have attributes, a constraint can have attributes, variables have attributes, and for example, special orders have attributes too. So this is information that you can set or get. It depends on the type of attribute, and some attributes are available all the time. Some are only available, for example, only after the optimization. So, and there's also something else that we call parameters. Parameters control the behavior of the algorithms. So that means you need to set them before you call optimize. And one more thing is if you create models in Gurobi, there is a model container, and this is what we call an environment. So an environment is a container for a set of models, and those have parameter settings as well. So we will see how this concept is used in the Python API in a few seconds. Okay, let's look at some fundamentals. So we want to know about the main functions that are available that we can use with the Python API, and several of them you already saw. For example, the read function. So we used it to create the model object from a model file. So sometimes you want to set a parameter. For example, if you want to tell Gurobi that you only have 60 seconds to solve a model, then this is what you would do. You can either do it globally, so that Gurobi knows for each new model you create, the time limit is 60 seconds, or you can also set this parameter on the model object itself, so that means it's specific to this model. And you can see it's always the same. You use the name of the object, dot the name of the property, and then you can either read it or set it. So here is, for example, the name of a variable, or you can print the right-hand side of a constraint. So we already saw the call to optimize, but probably the next more important function is set objective. So if we define a model, we usually have one objective function. So this is the function that we use to set the expression that is used as the objective function. And sometimes it's necessary to reset the state of the solver. So you basically reset the state that you had when you first read the model or created the model. So all the information from the optimizer is reset. So some more functions that are really helpful is, of course, it's not only important to create a model, but sometimes you want to access the objects. And that's where you can use, this is what we see with on the second bullet point here, so you can get the objects of the variables, the constraints, rows and columns, depends on how you access your model. And we also, this is the first bullet point, have functions that you can use to analyze a model or a solution. So you already saw print attributes, we used it to print out the value of all the variables, but you can also use something like print stats or print quality, which gives you more information about the model and the quality of the solution. And one more thing that is specific to Python, the way that control statements work. Python works by defining code blocks with indentation. So that means the code block is indented with spaces or tabs. So if you do something like a control statement like a loop, a for loop, then you define the loop, and on the next line, because that's the code block that gets executed, you put a few spaces, and then your command goes there. Same for something like a condition, like an if statement. This is specific to Python, and if you want to get familiar with Python, this is something you will get used to very quickly. In other programming languages, you use usually braces for this. Okay, so how do we build a model? Since you know that model creating involves multiple steps, we here at Gurobi, we propose that you use a certain workflow when you create a model with Python. So what we propose is, what we recommend is that you, at the first step, you create your variable objects, then you call a function update, then you set the objective function, and then you add your constraints. So why that? Gurobi has a transaction-based system to build a model. It means there is some overhead involved in allocating memory and setting up all the data structures. So it's much more efficient in terms of performance to first create all the variables, then do the update, and this creates the data structures in the memory. And after that, you use all the variables for your objective functions or for constraints. So you could also do it a bit different. For example, you could create a variable, call update, set the objective, then you add another variable, you do update again. So as a rule of thumb, try to keep to this workflow and try to avoid calls to update if possible. So the second thing that is very nice about Python is that you can use a syntax that is very close to the mathematical formulation. For example, here we have a linear expression or linear constraint that says 2x plus half of y is lower than or equal to 10. So you can basically take this and write this expression in Python code. So that's the thing on the right-hand side. So 2 star x, so 2 times x, plus in brackets half times y, less than or equal to 10. So that's it. That's the Python code that you need to build the expression. And that's very nice because it's very readable. So it means it's not that you need to convert your mathematical formulation to some function calls, but it allows you most of the time to keep very close to the mathematical formulation. Okay, so let's look at the first model that we are creating using this API. So there is a basic example that also comes with the Gurobi installation. It's called MIP1. And MIP1 is a very small example of a mixed integer problem that consists of 3 binary variables, so x, y, and z. And those 3 variables are decisions. So you want to decide about 3 activities, and those are binary variables, which means 0 or 1, do or don't do. So what you want to do is you want to decide which of these, or if all of these activities should be done, but there are some constraints. So the first constraint is you need to choose at least activity 1 or 2. So any feasible solution, you need at least one of these two or both. And there's also a time limit for the activities. So activity 1, which is X, takes 1 hour. Activity 2 takes 2 hours, and so on. And there is a time limit of 4 hours available. And it's quite easy to see that it's not possible to do all the activities. So an optimization here means you want to have the maximum value. So the value for X is 1, for Y is 1, and for Z it's 2. So and you see on the right-hand side a linear mixed integer problem of this problem. So what we want to do is we want to express this problem with the Python API and solve it with Gurobi. So we will do this with Jupyter Notebook. So this is just a reference slide that you can use later. So let me open up my Jupyter Notebook again, and then we can do this interactively. So this is the first demo. So I opened the second demo notebook. So let's take a look. As I already said, a very nice feature about Jupyter Notebooks is that you can also express formulas. So this is the LaTeX code behind, and if I press Shift and Return, this creates a very nice graphic with the formulas. So this is the problem that we just saw, and now we want to use the Python API to create this model in memory and use Gurobi to solve it. So we do this with the workflow that we saw, the 5 steps. So we start with loading the Gurobi Py module into our Python, and we create an empty model object. So we call it M this time. So and this model object contains nothing now. So the first thing, remember, that we want to do is we create all the variables. So we create an object X, an object Y, an object Z, and we use this using the addVar function of the model object. We tell Gurobi that these are binary variables, and we also give them a name. So as you see, you can also execute multiple commands here within the notebook. So now that we have our variables, I can call the update function, and then we set the objective function. So what you see here is that the expression here is very similar to the one that we have here. So basically it translates by just changing a little bit the syntax, but that's it. So this tells the model, you call this function of the model object, to use the objective function with this expression and to maximize it as the sense of the optimization. So then we add the 2 constraints, and we call them C1 and C2. And the only thing that we have to do is we have to formulate this as an expression in Python. That's it. So we have added our variables, we've set the objective function, we've added our constraints, time to solve it. So here's the output. All this is happening on my system right now. Yeah, and the last thing, of course, that we want to do is we want to take a look at the solution. So the log file also already tells us the best objective is 3, so that's the most value that I can get here. And of course, we want to see what's the solution. So we call this print attributes function on the model object, and here you see that variable X has value 1, Z has value 1, and that means Y is 0, because the print attributes function does not print values that are 0. So that means the optimal solution to our problem is choose activity X and Z. Okay, so let's go back and see a few more things. So if you need help with the API, we have many options. We have a reference manual online that you can see, so there is a good documentation on all the Python functions and methods, and there's a huge set of examples on the website and the Gurobi installation. So it's usually a good idea to take this and to go on from there and use this as a starting point to build your own model. One other thing that you can do is you can call the help function. So if you have an object or a class in Python, you can just use the help function with the name of it, and you get some text help, and you can use this too. You can also use this from Jupyter Notebook if you want. So this prints out some text and gives you some more information. One more thing is what happens if there is a typo, if you do a mistake. Does the notebook crash? No. If you make a mistake, then the way Python outputs an error message is by raising an exception. So you need to inspect it and take a look at it and see what happens, and then you can just change the code cell and execute the command again in the running environment, and you can fix things or you can change things, and this is like you execute the command again until you're fine. That's it. So I would say that in the beginning, it's very likely that you might struggle with the indentation. So maybe there's a space missing or one too much, and so that's what the error message looks like. Actually, you see it's an exception. It's called indentation error, and it has this circumflex character that shows you where there's a problem. So so you will see this in the beginning. But there's no problem, especially not in a interactive environment, because you can just change everything and then it's good again. Okay, so let's put everything together. So we want to do the full circle. We want to look at a real problem example and do all the steps from the business problem through the model generator to the model instance, to solving it, and to analyzing the solution. Before we do that, we talk briefly about 2 or 3 more language features of Python that we are going to use. Creating, for example, constraints usually involves iterating over a set of data, and there are many things that are very helpful here in Python. So we can use for loops and execute commands like adding constraints for every element in this loop. And the second thing that is also very nice is Python has a specific syntax for defining sets, for defining lists of objects. So this is what you can see here in the second example. So this says something like create a new list named penalty args, and this is defined by taking all the elements of another list, checking if some properties there. This is like filtering, and then you select the element again. So this is one line of code to filter a list and create a new list with this filtered data. And the third feature that we should look at is quick sum. So what happens is you create linear expressions, and linear expressions can contain many elements, and you don't know how many elements you get at first. So you need a function that you can use, and this is what it looks like. It's basically a replacement for the Python sum function. And what we have here is like we define, for example, an expression for the objective function, and it says we create expressions. For example, we multiply the cost associated with an arg here with a variable, and then we call quick sum on this set of expressions, and then we get the sum of all the sub-expressions. So this is also very easy. So to put this all together, what we do have now is we have a very nice way of translating mathematical model description into Python code. So this is the last example. So you see here is something like there is a set I, and for all elements of this set, I create a new constraint. And this constraint has on the left-hand side a sum of decision variables of x, which is indexed by I, and from another set j. And the left-hand side, the total sum on the left-hand side needs to be less than or equal to 5. So this was translated into Python code by using a for loop. So you make sure that you create this constraint for every element I. You call the add constraint function, and as a parameter, you give the expression. So you sum all the decision variables, which are objects in our Python API, on the left-hand side, and you take the rest of the constraint, which is less than or equal to 5. So what's really nice about it is that there is a nice mapping that you can see visually between the mathematical formulation and the Python code. So what is a good example? In fact, we have many examples on our website. So feel free to look them up and to play with them. Some are even interactive and graphical. So you can see the address here on the slide. And we've chosen a specific production planning problem because it's something that that we see quite often, and it's also a problem size that makes it possible to still describe the problem and to see what's happening. So production planning usually means we need to decide what to produce and how much. So these are our decisions, and when. And usually the objective is either to maximize profit or to minimize costs. So this is our objective function. And the problem has a lot of constraints. So it basically means we have a lot of constrained things in reality, like time constraints, resource capacities, and things like this. So this needs to be added to the model in order to get a feasible solution, not only for the model, but also for reality. So, and that's what we are going to do in the next step. We are going to take Jupyter Notebook, go over the decision problem, come up with a mathematical formulation, translate this mathematical formulation into Python code, execute, build the model, and then we analyze the solution. So, again, I'm going to open up my Jupyter Notebook. I open the third notebook. So this is also very nice about Jupyter Notebook because you see the whole notebook contains all the information. So I prepared a notebook where the whole problem description is already a part of the product. So let's take a look. So we start with the problem description. Consider a factory that produces 7 products. And for simplicity, we call them product 1 to product 7. And there is a range of machines that we can be used to produce these 7 products. We have grinders, we have drills, a borer, a planer. And now the question is, how many product units of each product should be produced in each time period? So, and of course, we need more information to decide this. And the first thing that we know is the profit contribution per unit sold. So that means we know that for 1 unit, for example, of product 1, the profit contribution is like $10. We also know how many units are, so let's put it like this. We know what resource consumption we need to produce a single unit of a certain product. So this is given in this table. So it means if we want to produce 1 unit of product 1, we need half an hour of grinding, 10% of an hour, which is 6 minutes for vertical drilling, and so on. So this is the resource consumption given for each product. Good. The next thing is we need to know our resource capacity. So from the problem description, we for example, know there are 4 grinders. But to make things a bit more difficult, we say that in each month that we can produce, some of these machines are down for maintenance. So in January, 1 grinder is down for maintenance, and so on. This is given in the following table. So the availability of resources changes over time, and we're not allowed to use more resource than what is available. The next thing that we have in our problem is a limitation on the number of product units that can be sold in a given month. So here is a table with the data that we will use. So we know that in January, only 500 units of product 1 can be sold at most. Good, and a few more things, and then we have our problem description ready. We also have inventory. So we are allowed to produce more units than we sell and put them into inventory. So there's limited space, so we can store up to 100 units of each product, but there is cost associated with it, so we say it's 50 cents per unit per month. So this is important for the objective function because it's costs. Okay, we start with 0 inventory in January, and we say for this problem we want to have 50 units of each product in inventory at the end of June. So one thing that is missing is time. We say we produce 6 days a week using 2 8-hour shifts per day. And we say each month consists of 24 working days. We don't look at sequencing, the order in which things are produced. So we just say if 1 unit of a product is produced, that there must be enough resources in total for it to work. Okay, so that's our problem. So we want to solve it. So we are looking for the maximum profit that we can make given all the data and given all the constraints. So the first thing that we have to do now is we put this into a mathematical formulation. So we create a linear optimization model. So, and this usually starts by defining sets. So, and we have 3 sets here. So we have a set of time periods, the month, with the T0, the first month, and TE, the last month. We have a set of products and a set of machines. So when we do it like this, because then we can show the code that is needed to create constraint out of a dynamic set. So the model generator stays the same, and you just change the data. So you can, for example, adjust costs or change capacities, and you can just run the same model generator again and solve a different instance. So we have parameters. So this was given in the tables already. So we have something like the time it takes on a certain machine for a product unit to be produced. We have a sales limit. We know the profit. We know the number of available machines per month. And we also know that each machine can work G hours a month, and that Z is the number of products of each type that can be stored each month. Storing cost is R. So that's our parameters. So let's look at the variables. We have 3 variables here, V, U, and S. So for every combination of period and product, we decide how much we produce, which is V, how much we sell, which is U, and how much we store, which is S. So this is a non-negative variable because it wouldn't make sense to produce a negative amount of products. So the objective function is we maximize the total contribution to profit minus the inventory costs. So this means we sum over all products, all periods, and we create an expression that contains the profit contribution times the amount that we produce minus the storage amount and the storage cost rate. So that's it. So we need to create constraints. So, and the first type of constraints that we need is our balance constraints. So we need to make sure that inventory is included and that we follow a rule. And it's like this. So this is to read the first constraint. It basically says for each planning period, make sure that the amount that was in the inventory in the last period plus everything we produce is always the same as the number of product units that we sell plus what's in inventory at the end. So, and of course, we have this end store constraint, so we need to make sure that we have the right number of units in store at the end. And of course, we need to start with a certain amount because at the beginning the storage is empty. Okay, so 2 more types of constraints, and then we can go over the Python implementation. We have store capacity constraints, so this makes sure that we do never store more than what is the capacity for each combination of product and period, and we make sure that we do not exceed machine capacity. That means for each period in each machine, we make sure, this is the expression on the left-hand side, that the amount of resource needed to produce the amount of product units is less than the available time multiplied by the number of machines. So we make sure that we never produce more than, so that we cannot produce more than what is available with our machines. Okay, so then we go over the Python implementation. We go over this a bit more quickly so you get the idea, and I'm sure if you're interested, you will have a deeper look at it afterwards. So now we can immediately execute code. So this is what happens here. We start by importing the Gurobi module. and then we define the data. So this is just another way of writing the data that we already saw in the tables. So, and we define lists and we define dictionaries. I will not go into detail, but I will just execute it so that we have to make sure that we have all the sets, all the information available. So this is using certain constructs, for example, like a multi-dictionary that we use to create the dictionaries that contain the data. So you can look this up in the notebook if you're interested in all the details. What this basically does is it creates Python objects that contain all the data that is important for this model. So we'll just execute this. So in memory, we already have now the data. So that's it. And now comes the part where we create. So now is the time for the model generator. We have the same workflow that we've already seen in the previous examples. So what we do is we first create a model object and we name it factory planning. Then we create the variables. So what this code block here does is for all months and for all products, it creates a variable and it's calling the addVar function, like you already see, creating a continuous variable for manufacturing, for holding, and for selling. So we created our variables and we call the update function. So now Gurobi knows about all the variables, and now we can create our constraints. This is the code that is used to add the balance constraints that is used for inventory. So this is basically the same that we already see. It says like for the first period, all your manufacturing must either be sold or held in inventory, and for the next month, you make sure that that you also include the amount that was in inventory in the last period. Okay, so let's go over this. So we add constraints for the end stock, so we make sure that at the end we have everything in stock that we want. Then we create our constraints for the machines. So this is basically using all the things that we already used, like quick sum and list comprehension to define the lists of objects. As I said, I won't go into too much into details, so that you get the idea. And finally, we create the objective function. So this is the expression that is also the same as the mathematical formulation. We sum everything together, so we calculate for each product and month the product of profit contribution and the amount we sell, minus the storage cost and the amount in the inventory. So at this point, the whole model is generated, and the model instance is available in memory. So all we have to do now is we call optimize. So, and if we call optimize, Gurobi is executed and it calculates the optimal solution for this model. So this is very quick. And now we do the same thing again. So remember from the cycle, we had our problem, we had the data, we created a model, a mathematical model, and we used this to create the model generator. We optimized the instance, and now we have a solution. And now we need to look at the solution. So we could use the print attributes function, but yeah, this shows us a lot of numbers. So it's not that easy to read. So it should be easier. And that's the last very nice feature of Jupyter Notebook that I'd like to show you is, for example, what you can do is you can use Python code to create HTML, like website code, and define a table. So, and if I execute this, this generates a table using the values from the decision variables. You can spot point X here. So this uses the X attribute again. And if we do this, we get a nice table of the results. So for each month, which are the rows, we can see for each project how much we manufacture, how much we sell, and how much is held in inventory. So this is the full circle. Now we have a nice overview of the result. We can do further analysis, and maybe we start it again if we change capacity constraints or something. So we can do this interactively within Jupyter Notebooks. So let's go back to the slides. feel free to use our online examples. So we have online resources with interactive examples, and we also find this factory planning example there. So everything's there to help you and that you can use to start. But there's more. We encourage you to use this as a starting base to build your own model.